Okay, question number 8 is a simultaneous equation question, and we're looking for answers for n as well as m and n, and I'll notice I've got an n there. So just to recap, if the determinant equals 0, therefore parallel. So that could be no solutions or it could be infinite. If the determinant doesn't equal 0, therefore not parallel, therefore unique. And unique is another word of saying one solution. Okay, so I'm going to work out the determinant of this. The determinant is going to be m times m squared minus 1 times 9. So the determinant equals m squared minus 9. And if I set that equal to 0, I'm going to have m squared equals 9, m equals plus or minus 3. So there are two situations, m equals 3 and m equals minus 3, that will give me parallel. So if I'm looking for one unique solution, therefore m has to be anything except -3 or 3, because it's when m equals -3 or 3 that I have parallel. And when I've got parallel, I've got none or infinite. It's when they're not parallel that I have unique. So m can be anything except -3, and n can be anything, because it doesn't matter what n is, because the two lines are not parallel. Okay, now let's explore what happens when m equals 3. When m equals 3, my equation becomes 3x plus 9y equals 15, and x plus 3y equals n plus 2. Now I can see that if I multiply my bottom by 3 times that gives 3x, 3 times that gives 9y, 3 times this gives 15. So n plus 2, if it equals 5, therefore n equals 3. So when n equals 3, I will have infinite. So looking at that then, to have infinite solutions, m can equal 3 and n equals 3. And that will give me infinite solutions. Therefore, no solutions is when m equals 3 and n is anything except 3. Because if m equals 3, it's parallel, but if n doesn't equal 3, they're not the same. And now I need to explore what happens when m equals -3. When m equals -3, I get -3x plus 9y equals 15, and x minus 3y equals n plus 2. Now in this occasion, if I multiply that by -3, that will give minus 3x. -3 times that's plus 6y. So -3, I'd want n plus 2 to equal -5. And then -3 times -5 gives 15. So n equals -7. That's going to give me the infinite solutions. So for my infinite solution answers, if m equals -3, n has to equal -7. And if m equals -3, n can be anything except -7. So I have, for my unique answers, these solutions. M can be anything except negative or positive 3, and n can be anything at all. Then I explore what happens when m equals 3, and I will have infinite solutions only when n equals -3. And when I explore -3, I will have infinite solutions only when n equals -7, which means I will have other parallel lines that will give me no solutions whatsoever when the two equations are not equal, and that will be when n is anything except 3, or when m equals -3, n is anything except -7.